you had a few problems here. We're checking if it has one solution, no solutions, or infinite number of solutions, right? So the easiest way is to just start solving and see how far you can go. So, first one, 36 minus 7p. On the other side is negative 7 times p minus 5. So let's take care of this distributive property right here. I get 36 minus 7p. On the other side, I'm going to get negative 7p plus 35. Negative times a negative is plus 35. Now, if you look at it, they look very, very the same. The negative 7p's and the negative 7p is the same. But the 36 and 35, it's not. So I'm going to already tell you that this, right, if you've been looking at patterns and similarities, looks like it's going to be an equation with no solution. Well, let's continue anyway. So if you continue, the next step would be to get rid of the variable. So I'm going to do plus 7p here and plus 7p. It didn't matter which one you want to get rid of because they're both the same. So anyways, minus 7p plus 7p goes away. I'm left with 36 on this side. And minus 7p plus 7p on the right side goes away as well. And I'm left with 35. So notice that this says 36 is equal to 35, which is not true, which is going to lead us that this is an equation with no solution. This one, distributive property, 4k minus 32 equals negative 32 plus 4k. Now, I know they want to be a little tricky here, but what we can do is just rewrite the right side. Remember, this is 4k and this is minus 32, so I'm just going to change the order, bring the 4k to the front and the minus 32 to the side, and notice that they're exactly the same. Whatever I do to the k on the left side is exactly the same as what I'm going to do to the k on the right side. So if you wanted to continue, as far as we go, we can now get rid of the 4k, right? One of them. We're going to do minus 4k here, minus 4k here. The 4k's are going to go. Minus 32 is going to be left over here, and this same thing. Minus 32, and notice that they're equal to each other, right? So that tells you that whatever you do to whatever value of k it is, they're going to give me the same exact answer on the left and the right side. So this is all real numbers. Four, and again, a lot of them have distributive properties, so just change it. Negative 2v plus 4, right? Because a negative times a negative is a positive. And then there's negative 3 minus 2v. You want to change the order. I'm going to bring the minus 2v to the front. And I'll take the negative 3 to the back. Very, very similar. The v's are the same, right? They both have coefficient negative 2, but the 4 and the 3 are different. I'm just going to continue this. The next step here, right, would be to get rid of one of the coefficients. Sorry, one of the variables. So let's get rid. They're both the same. So we're going to end up doing plus 2v here and plus 2v here. If you do that, the v's goes away on both sides, but you're left with 4 equals to negative 3, and that is not true. Which means, in this case, that there is no solution. Same thing here. There's an invisible one. Put it. Negative 3. Negative times a negative is positive, so we get 6b equals 6b plus 5. So I think you've noticed by now, if the variables here have the same exact coefficient, on the left side I have positive 6b, on the right side I have positive 6b, and then on the left side I have minus 3 and plus 5, the b's are going to be multiplied by the same coefficient of 6, but after they're multiplied, on the left, you're subtracting 3, but on the right side, you're adding 5. So there will never, ever be the same amount. So just to continue this a little further, we get rid of the variables. We do minus 6b and minus 6b. This goes away. I'm left with negative 3. This goes away. I'm left with positive 5. And obviously, that's not a true statement, which makes this a no solution equation. 8x plus 38. This is going to give me positive 18. Oh, sorry, just 18. And this is going to be negative 3 times negative 4x is positive 12x. This looks like a very regular equation. Let's continue this. There is no distributive property I have to care of. Combine like terms, I can't. There are variables on both sides. There are. So we're going to get rid of the small one, which is 8x. So let's do minus 8x here. Minus 8x here. These two go away. I'm left with 38. This is 18. 12 minus 8 is 4x. Again, it just becomes a two-step equation, right? So we're going to do minus 18, minus 18. We get 4x equals 20. Divide both sides by 4, divide both sides by 4, x equals 5. So therefore, this is a one solution equation. Okay. 20, 12 plus 4n. Let's multiply this, it's 4n. Let's multiply these two, it's 12. So if you notice, they're exactly the same. Whatever happens to n on the left is going to happen to n on the right. They're both being multiplied by 4 and added up 12. So this one is all real numbers because it doesn't matter what n is. It's always going to equal to each other. And then I'm just going to continue this one more step. Let's get rid of the variables. Let's do minus 4n and minus 4n. This goes away. We're left with 12 equals 12. So that tells you that this equation is all real numbers and can be any number in the world and it will work. 8. Ooh, there's 3 more. Negative times a positive, negative 3v. Negative times a positive is negative 12 equals 2v minus 37. So this one, I think, is just a one solution. Let's continue. Distributive property check. Combine like terms. I can't. Is there variable both sides? Yes, there is. Who are we going to get rid of? I'm going to get rid of the minus 3v by doing plus 3v. Plus 3v here. That goes away. Negative 2 comes down. 2v plus 3v is 5v. Minus 37. That's my little story. I have a variable v, which is being multiplied by 5. Subtract 37. Gives me negative 12. I'm going to do the inverse operation, so it's plus 37 and then divide by 5. So, plus 37, plus 37, that goes away, 5v comes down, and this becomes 25. Now we divide both sides by 5, v equals 5. So this was a one solution equation. Distributive property, negative 16 minus negative 32m plus 28m plus 4m equals negative 72. This looks like a one solution type problem. So let's combine like terms. Yeah, we combine this guy with this guy with this guy. Wait a second, I take that back. So negative 16 and then negative 32m plus 28m plus 4m is equal to 0m. I'm going to write 0m for now. Equals negative 72. And then if you, obviously 0 times m is just 0, we end up having negative 16 equals negative 72. Right, because that's just 0. Is that a true statement? No, it's not. So I take it back. This is a no solution. No solution. So it doesn't matter what happens here, right? Whatever value of m that you replace here, right, they're going to be canceled out because whatever you get on the whatever value of m you get here and you multiply by 32 negative, it's going to be canceled out by the 28m plus 4m because it's the same, right? It's the same thing as 32m. So this becomes a no solution because imagine that this is just 0. This is eventually just going to become 0 and you're left with negative 16 equals negative 72 always, right? So that there is no solution for this one. Last one, 267 equals 40n, distributive property, plus 20 plus 7, right? Distributive property is gone. Can I combine like terms? I can. Let me just make some room here. So I'm just going to combine like terms. So 267 equals 40n plus 27. I'll bring it up to the top here. 267 equals 40n plus 27. This looks like a one solution. I'm going to go ahead. Oh, I'm not. Maybe I jumped the gun on the previous one. That was wrong. So here's my little story. I have a variable n, which is being multiplied by 40, and then add 27. I have equals 267. So I'm going to do the inverse operation of plus 27, which is minus 27, and then divide by 40 on both sides. So minus 27, minus 27. That goes away. 40n comes down. This becomes 240. Divide this by 40. Divide this by 40. And 40 divided by 40 is 1, or 1n. And then 24 divided by 4 is just 6. So n equals 6. So the last one is the one solution. Okay, so yeah, that's it for today. That's it for that.